Right, look at the seventh question. Which of the following statements made regarding seismic waves is incorrect? So remember, they're asking for the correct statement. Highlight it. So the first statement, all seismic waves are mechanical waves and require a medium to propagate. Exactly correct. Now these questions are made from the theory book directly. So you have to master the theory. It's not very logical. So just the knowledge-based question. Right, so seismic waves, when you're talking about seismic waves, you're talking about earthquake waves. So here, these seismic waves are mechanical waves. It's correct. So they are mechanical waves. They can be, these seismic waves which are mechanical, they can be transverse or they can be longitudinal. Right, so, and they also require definitely a medium to propagate. That's 100% correct. Now, why do you say that? They do require a medium to propagate because they're mechanical waves. Mechanical waves need a medium to propagate. But if you look at electromagnetic waves, they do not require a medium to propagate. Right, so statement 2, primary P waves are longitudinal and secondary S waves are transverse. What do you say? Yeah, that statement is correct. Primary waves are longitudinal and secondary waves are transverse. Primary, longitudinal, secondary, transverse. You can write it like this. Transverse, that is sound. Secondary, transverse. But P waves are longitudinal. There's no S there. So you can write it like that. It's very easy to remember it. Okay, so then the next one is the third one. Speed of S waves is less than that of P waves. Correct. So these are directly from the book. Fourth statement, S waves can travel through both liquid and solid media. Now this statement brings about many important conclusions and facts. Now listen, this is a very important statement. When you talk about electromagnetic waves are transverse waves. But these electromagnetic waves, which do not require a medium to propagate, can travel in any media. They can travel in the liquid too, you know that, and in solids too. So it's not a problem for electromagnetic waves, which are transverse waves. So if there's a statement saying that transverse waves cannot travel in liquid media, that's wrong. Because electromagnetic waves, which are transverse waves, can travel in liquid media. But mechanical transverse waves cannot travel within liquids. Within liquids, that word within is very important. In liquids. But transverse waves can travel on top of liquids, on the surface of liquids. Remember water? The wave of water, the water surface, this is transverse wave. But transverse mechanical waves cannot travel within liquids, but longitudinal waves can travel within liquids. So if you look at secondary waves, they're transverse waves. Therefore, they cannot, and what kind of waves are they? Mechanical transverse waves. That's a very important word. Secondary waves are mechanical transverse waves, therefore they cannot transfer within liquids. It's a very important point. So the fifth one, so the fourth statement then is wrong because they have said S waves can travel through both liquid and solid media. It's a wrong statement. Fifth one, P waves can travel through both liquid and solid media. Yeah, that's correct because P waves are longitudinal. Therefore, they can travel through both liquid and solid media. It's a great statement. Right. Look at the 8th question. A narrow beam of monochromatic light XY falls on a converging lens L as shown in the figure. After refraction through the lens, the beam hits the screen S and makes a light spot. What would be the position of the light spot? It's very easy. Let's look at it. Now, I have the lens like this. There we go. So we have the ray coming like this. A ray passing through the center doesn't undergo refraction, it just goes through. And do you know, when parallel rays come like this, they have to be meeting in the focal plane. So, we'll mark the focus. The focus is here. The focal plane is like this. So, they meet in the focal plane. So, remember that theory, that they meet in the focal plane. So, this ray should be meeting this ray. So, we'll consider xy. And if you have a screen here, this continues to touch somewhere like this. But most students are confused with this ray. Now this ray goes like this, but this ray goes and strikes like this. So the image is formed here. Right. You can see the ray striking here. Okay, so the next one. 9. Positions of particles of a transverse wave traveling along the plus x direction at a certain instant is shown in the figure. A pair of particles with same instantaneous velocities is. So what can we do? So the image formed here, it's just the ray striking here. So remember, so light spot can be seen there. Right, so the next one. So you have to represent the positions like this. Okay, so we have B here, and C here, D, E, and F. What you should do is, after some time, you have to mark the position of the wave. So this X and this displacement. So this is direction, X is the direction of propagation of the wave. So after some time, what's happening is this. The wave goes like this. Something like this. So look at B here. You can do this at home. The velocities at B and F have the same directions and the same magnitude. Now, same magnitude and same direction means same velocity. If you look at a particle like this, it's going like this. A particle like this goes up like this. Magnitudes can be equal, but directions are different. Therefore, their velocities can be different, but speeds can be equal. So, look at positions B and F. So, what's the answer? First one. Right, 10th question. A small instrument of mass 1 kg is placed on a planet. The mass of the planet is 3 times and radius is 2 times that of the Earth. What would be the weight of the instrument on the surface of the planet? Neglect all other effects except gravitation. Right now, you know, if you consider the Earth like this, the gravitational field intensity at point A, a distance of r from the center of the Earth, is equal to gm divided by r squared is equal to g. If we consider a planet of mass m and having a radius of r, then the gravitational field intensity at the surface of the planet is equal to gm divided by r squared. Right, so knowing this, what can we say? G is constant for all the planets, universal gravitational constant. That's why it's called universal gravitational constant. Therefore, G is proportional to m over r squared. Now you know gravity at the surface of the earth is equal to 10 roughly. So they've given that. Yeah. Right. So what will be the weight of the instrument on the surface of the planet? So in the earth, now if you have 1 kg, what's the weight? 10 newtons, no? But this 10 newtons you got because you know the gravity of the earth is equal to 10. 1 times 10 gives you 10 newtons. Now, the gravitational field intensity of 10 is proportional to what? Mass of the earth divided by radius of the earth squared. Now I have the unknown planet which has mass 3 times that of the earth and radius 2 times. That means the gravity at its surface, g, is proportional to 3m divided by 2r entire thing squared. So that gives you a 4r squared. So can you understand? It has become 3/4 of the amount of earth. Now 10 is proportional to m over r squared, which is for the earth. The gravitational field intensity at the surface of the earth is 10. But in the planet I'm considering, it is 3/4 of the value of the earth. That means it is equal to 10 times 3 over 4. That means g is equal to the gravitational field intensity at the surface of that planet is equal to 10 times 3 over 4, which gives me 7.5. So now gravity is 7.5. If you multiply g, gravity, by the mass 1, you get 7.5 newtons, which is 15 over 2. So the answer is the third one. So you can do such questions mentally. You know that Jm over r squared is equal to gravitational field intensity. So if you can see mentally that mass increases by a factor of 3 and radius increases by a factor of 2, we get m over r squared to be equal to 3m over 2r entire thing squared. So we get 3m over 4r squared. That means 3/4 of the previous gravity. That means 3/4 of the gravity of the earth. That means 3/4 of the weight of that object on the earth. So I think you can understand this, right? So the other questions we'll be discussing in the next video. Thanks for listening.